Okay, good afternoon, year 12, calculus. As promised, I will do questions 3 and 4 for you on page 15. All right, let's look at number 3. Well, number 3 is a graph doing this, and this, if you look at it and you remember the original or the beginning cubic graph that you remember doing, then you can see that this is another cubic graph. However, it's going to be if this form, of course, y equals x cubed, but this y equals x cubed, this stationary point here where the cursor is, it has been moved 3 units in the positive x direction and 1 unit up to this point here, 3, 1. Now that helps us to build the altered equation. So instead of y equals x cubed, we know it's going to be y equals k brackets x minus 3 all cubed. Minus 3 because the original cubic has been moved 3 units in the positive x direction. So we must write a minus sign here. Okay? And it's going to be all cubed. Then the graph has been moved up 1. And that's what this plus 1 at the end is all about. So we know that the equation must be starting like this. Now I've used this point here, 4, 2, which sits on the graph, to find k. You can't use this stationary point value because if x is equal to 3, look what's going to happen if you put 3 in there for x. 3 minus 3 is going to give you 0. The k is going to disappear, and you can't find the value of k if that happens. Okay, so you can't use this point. You could use this point, which is 2, 0, and you will get the same value for k as if you use this point here, 4, 2. However, I have used the point 4, 2, and I used it to find k. I put 2 here for y, and for x I've written 4, and 4 minus 3 is 1, so that's 1 cubed. I've taken this plus 1 here over the equal sign to go minus 1. 2 minus 1 is 1, so 1 is equal to k times 1 cubed. 1 cubed is 1, so k is 1. So the complete equation is that. Okay, there's a 1 here in front of the brackets. Y equals x minus 3 all cubed plus 1. Now, in the features, we can immediately list the fact that this is a positive cubic. Now, positive because it is going from this bottom corner on the left up that way to the top corner on the right. So if the graph's sloping this way, then like that one is, then it's a positive cubic. And there's a stationary point at 3, 1, like there is there. And there are x-axis intercepts at 2, 0, which is that point there. And then, of course, if this was to continue down, at some point way down here, there would be a intercept on the y-axis. Now, what I've gone and done, of course, that would happen at x equals 0. So if I put x equals to 0 in this equation here, I will get minus 3 all cubed, which would give me minus 27. But it would be minus 27 plus 1, which is then minus 26. Now, in my haste to do the answers, I wrote minus 27 here as the y-axis intercept. This, of course, is not right. So be careful about that. Even I can make mistakes. Einstein can also make mistakes. So, yeah, so that should read minus 26. Now, the domain is, of course, where are the values of x that for this graph is possible? Well, all the values of x, you can draw a graph like that and keep on drawing it up there and down here. And the same is true of the y. There's no values at which the graph starts or finishes along y. It goes up that way to infinity and down that way to infinity. So it's all values of y for the range and all values of x for the domain. Okay, now let's look at this next one here, question 4. Well, we've got the graph doing something like this. It's got an intercept there, intercept on the x-axis there and there, also there, but this point there, sorry, is an intercept on both the y-axis and the x-axis, which is the origin. Okay, now if it's cutting the x-axis in 3 places, there, and there, we can immediately build up our equation using the intercepts. Okay, we can write y equals k, x plus 0, x minus 1, x minus 2. Of course, x plus 0 is just x, which is what I've done there. So a more grown-up way of doing it is to say y equals kx, brackets, x minus 1, close your brackets, open your brackets, x minus 2, close your brackets. Okay, now when you look at the graph that is in the booklet, you'll find it's very difficult to find a unique point through which this graph goes, but there is one there. If you look, it's near the top and it's at the point -1/2, 2, and they're the values that we're going to use to find k. Okay, now it does get a little bit hairy because of the hairy scary because of all the fractions, but keep a clear head and we should be okay. So we're going to put these values here into the equation to find k. Well, y is 2, so 2 equals k. Now my x, this x there is -1/2, there it is. And this x is -1/2 there, but it's -1/2 minus 1 in brackets. And here we've got x, which is -1/2 minus 2 in brackets. Now, this is, let's do this one first. -1/2 minus 1 is -1/2, which is the same thing as -3/2. You can think of -1 as being -2 halves. Yeah? So you've got -1/2 minus 2 halves is -3 halves. Look at this one here. 2 is 4 halves. So you've got -1/2 minus 4 halves is -5 halves. Now, these brackets are telling us that these 3 fractions, -1/2, -3/2, -5/2, are all being multiplied together. This means that we can multiply the denominators 2 times 2 times 2 to get 8. And then 1 times 3 times 5 gives 15. We have to be a bit careful with the signs because we've got a minus timesing a minus, so that's going to go to plus. But then that plus is going to get multiplied by that minus, so the whole thing is going to go to minus. So that's really -15/8. And what I've done is I put the minus sign at the front here. Okay? Now I've done that because I'm going to now cross-multiply this 8, cross-multiply it up by the 2, and this 15 down below the 2. So I get the answer there, 2 times 8/16 is -k. Now I want a value for k because I've got a value for -k. So if I multiply by -1 on both sides, k will go positive, and this thing here will go to -16/15. Okay, which as a decimal is that thing there, -1.06 recurring. So the final equation for this curve is y equals -16/15x, x minus 1 in brackets, x minus 2 in brackets. Now, if we look at the features, we can see that it is a negative cubic. Negative because if you look at it, it is a cubic, but it's starting in this top left-hand corner and going down to this bottom right-hand corner. So it's sloping sort of like in that way. So that's what when we call it a negative cubic. and it has stationary points at this little squiggle there means about, because it's very difficult to see exactly where those stationary points are. We're talking about that one there and that one there. Now, in my estimation, they are stationary points at about x equals 0.3 and y is minus 0.3, and another one at x equals 1.6 and y equals positive 0.3. The x-axis intercepts, of course, are where it crosses the x-axis, which is at the origin 0, 0, at 1, 0, and at 2, 0. And the x-axis intercept is in fact the origin itself. And again, because the graph goes to infinity in both directions, we can say that the domain is all values of x and the range is all values of y. Okay, we'll be doing some more as the days go by. That's in graphs 5, 6, 7, and 8, maybe tomorrow. Okay, I might set them for homework, so be careful. Okay, thank you very much. Bye.